So guys, forgive me, I am a little congested. Um, but, any- but anyways, we have to design a 0.8 amp fused and the fused material in our stockroom melts at a current density of 450 amps per centimeter cubed. We are looking for the diameter of the wire and the answer is 0.48 millimeters or 4.8 times 10 to the negative fourth meters. According to the according to the problem, I have the green check over here. So anyways, here's a cylindrical fuse. This is not the fuse that's shaped in a U, or like a rectangle with two prongs at the end. It's 0.8 amps, and we are looking for this purple line, even though the purple line's a little over the yellow wire. The wire is thicker than usual. So yeah. So we are given that the current density is 450 amps per centimeter cube. Uh, so we have to turn this into SI units. So we have to multiply the 450 amps per centimeters cubed by 1 times 10 to the fourth centimeters cubed over 1 meter, because there's 1 times 10 to the fourth centimeter, squared centimeters in a square meter. So yeah, and all the square centimeters cancel out, and you would get 4.5 times 10 to the sixth amps per meter squared. So the definition of the current density is the current the current divided by the surface area of a surface. So this so so we are looking for the diameter of a wire. And then so we have to get the surface area of the ends, which is essentially a circle. Um, so we have to get the area of a circle, which is pi r squared. So so and now we have to replace the r. You have to replace the r in terms of d, which is the diameter, and the radius is equal to diameter divided by two. Well, two r is equal to d, but then we just divide both sides by two. So r is equal to d over two. And now we plug that in for now we plug d over two for r, and then it becomes a is equal to pi times quad d divided by 2 squared. Or if you just want to splice it all together, it's pi. It is pi times d squared over 4. And now we plug that in for a, and then we will get that it equals 4 4 times I pi over pi times d squared, even though it's actually I over quantity pi over d squared divided by 4, but it's just the same thing. So now we just follow this arrow, and then it becomes and then we mul- we mul- we multiply both sides by d squared, and then we divide both sides by j as in Juliet. So so and then after that we square root of both sides. So d as in Delta is equal to the square root of 4 I as in India over j as in Juliet times pi. So so basically the diameter is equal to the square root of 4 times the current over the current density times pi. So now all you got to do is plug the numbers. So I as in India is equal to 0.8 amps. Of the current is 0.8 amps, and then J as in Juliet, or the current density is 4.5 times 10 to the fourth power, and then so it's 4 times 0.8 divided by 4 4.5 times 10 to the fourth times pi, and then you square root that, and and then your answer should be similar to 4.76 times 10 to the negative fourth meters squared, or in this case, 4.8 times 10 to the negative fourth meters, or just 0.48 millimeters. And that's your answer for problem 27.55. If you like this video, please drop a dislike, and I'm sorry for wasting your time. See you in the next physics explainer video.